This is Algebra 1, test number 1, or spring test number 1. It's our study guide. First question, we have a few multiple choice questions that pop up. It says, which number is a solution of the inequality? And then they give you 4 options. You have to see, not red, you have to see that it says 12J is greater than or equal to 12J. When you solve that, it doesn't tell you to solve it, but 12J, I'm not 12J, I'm sorry, 12 is greater than or equal to 12J. If you wanted to get J by itself, that says 12 times it. You just divide by 12. Do likewise over here, and you're going to get the number 1 on this side. J still on that side. I can't talk and write today for some reason. You're going to get 1 on that side and J on that side. You divided right there, but you divided by a positive number, not by a negative number. So you don't need to reverse the symbol since you divide by a positive number, not a negative. So you leave the symbol just like it is. Remember, when it comes time to graph and when it comes time to looking at this stuff, it's a whole lot easier if your variables first. Notice it's backwards on here. So if you just change their positions and you put J first, and then 1 second, make sure the mouth again is eating the bigger number, so it's eating a 1. So that says J has to be less than or equal to 1. The only number that satisfies that criteria is the last one, 1. Less than or equal to. All the rest of them are larger than or greater than. So 1 in that case will be it. Number 2 says 3x minus 9 is greater than or equal to 4. Again, when you solve this, greater than or equal to, you take care of the subtraction first by adding 9 to both sides. All we did was added right there. So that's going to be 3x. Since we added, we don't reverse the symbol. We leave it just like it is. 4 plus 9 is 13. And then when you divide by 3 on both sides, you get x is, again, all we did was divided by a positive number, not by a negative number. So you get x is greater than or equal to 13 over 3. When we look at all of the numbers to see which one it is, the one we solved for, 13 over 3, actually pops up, so we don't have to go through them and determine which one's actually greater than. If you have any questions about it, you can see that this one's a partial number, 1/4, so it's not quite even big enough to be greater than that. When you're looking at the number 2, if you're comparing 2 to it, you might want to at least change this into a mixed number where you can see how big it is. 3 goes into the number 13. It goes into 12 4 times, and there's 1/3 left over. So look how much bigger 4 and a third is than all the rest of those numbers, with D being a negative value. So it has to be C in that case. The number you solve for anyways, 13 over 3. Identify the graph of these inequalities. It says x is at most. So it has at most. It doesn't use less than or greater than. You have to determine what at most is. So x and 3.5, and then you're going to fill in that number right there. So x is at most. That means it's not going to be any bigger than 3.5. But it can be the same size as 3.5. So it's either 3.5 or smaller. So x is less than or equal to 3.5. That would be the algebraic version of the verbal model that's given. You need to do the graph of it. So at 3.5, notice this one right here is negative 3.5. That's not it. The rest of them are at 3.5. This one is showing going to the right. Notice that's opposite of the way that we're graphing. So it's not this one or this one. So it's either going to be C or D. Notice they're exactly the same, C and D, except one of them has an open bubble and one of them has a closed bubble. Remember, to determine which one it is, if it says or equal to at most, you have to know that it can be the number 3.5. So that means to count the number, which means it's not this one. It has to be this last one right here, the colored in bubble, D. Number 4 says write an inequality in words, or write the inequality in words. 3, if we want to write it out in words all the way, we would say 3 times n is less than 52. 3 times n is less than. This is the part they really want you to focus on right here, is less than. You know that 3 right next to n means to times it. You know that means to multiply. You need to, it's just distinguishing which symbol you're looking at. Remember, if you get confused with which ones they are, just tilt your head to the side a little bit and you could write the word, you could write the phrase less than with this one. You can't do that with the greater than one. Number 5 says graph the inequality. P is less than 2. All you need to do is, when we're sketching the inequalities, when you're doing a multiple choice test, there'll be a whole bunch of little tick marks and you'll go exactly to the number 2. But when you're sketching these graphs, since it's positive 2, just put 2 numbers and just put 2 on the right-hand side of 0, indicating that it's positive and not negative. Less than means we're not going to count the number, means we're not going to fill it in. So leave the bubble open. And then less than, notice since we have our variable first, its arrow is pointing that direction to the left, so we're going to shade to the left. Another way that you can determine that, you can say, well, it says less than, that starts with an L, or that has an L in it, so I go to the left. Number 6 says x is greater than or equal to -4. Same thing when you're graphing it, just show 2 numbers. Since it's negative, put it on the left side of 0. Now that's just indicating it's a negative value where you can see it. Greater than or equal to, the or equal to part, unlike number 5, means to color it in. And then since the x is first, again, just like the p was first for number 5, go the same direction it tells you on the arrow. It points to the right, and it goes that way. There's a graph. Again, greater than has an R in it, go to the right. Less than had an L in it for number 5, go to the left. Number 7, write an inequality for the graph. Use x, since that's what we're most familiar using. X, and then this one's at -6, -6. So all we're going to do is we're going to fill in an inequality symbol. Okay, I tried to put that blank real low the way you don't think it says or equal to. But x is something -6. That's what you're doing. It doesn't say or equal to because it's an open bubble. So it's pointing this direction. Notice what that symbol looks like. That's the one you're going to put. X is greater than, again, not or equal to, because it's not a colored in bubble. The other one, we're going to say that that is -1/2. If you're unsure, you have to estimate in problems like this. X is something -1/2. If you pick -2/3 or whatever, nobody can really fault you for that. Again, you're not going to be writing it. You're going to be choosing from a multiple choice answer. You won't have to choose between -1/2 and -2/3. You might have to choose between -1/2 and +2/3. You got to know that that's not a positive number. That's a negative number there. Okay, but again, it's colored in this time, unlike it was in number 7. So it's going to be or equal to no matter what it is. And then just like number 7, it's pointing this way. So you go in that direction. Just like number 7 was, it's greater than, this time is or equal to -1/2. Number 9 and 10, we're writing an inequality to model situations. Thomas earned $44 or more. It is much easier to write the variable first and the number second. X is something 44. $44 or more. That means he didn't earn 43. That either means he earned 44, 45, or anything that's larger than that, all the way to an infinite amount. So the value he earned is what X is. X is greater than or equal to, because he could have earned $44, but it had to be bigger than that or equal to that. X is greater than or equal to. A number exceeds, think about exceeding the speed limit. Going 35 miles an hour is not enough to get a ticket if the speed limit is 35 miles per hour. So in order to exceed it, you got to go 36. In this case, the number exceeds 32. Again, a number exceeds 32. It is not or equal to in this case, because for going the speed limit, you don't get a ticket. You have to exceed it. You have to go larger than the speed limit. So X is greater than, not or equal to 32. And we're solving and graphing the inequalities. X minus 7 is less than or equal to -12. You undo -7 by adding 7 to both sides. X is something, -7 plus 12. Think about where you're on a number line. You start all the way to the left of 0. You go 7 times to the right. You hadn't quite got back to 0 yet, so we're going to be at -5. All we do is add 7 right there. We did not multiply or divide by a negative number. So your symbol that said less than or equal to remains less than or equal to. That's solving it. Then graph it. You have your you have your variable first. You're showing two things. It's negative, so show it to the left of 0. Less than or equal to means you color the bubble in, the or equal to part. Less than means you're going to the left. Here's the graph. So when you're choosing multiple choice answers, again, if you take a test like this and you're choosing multiple choice answers, what you need to do is there may be one where it's solved correctly and graphed wrong, and vice versa. There may be one that's graphed correctly and solved wrong. You have to choose the one that's correct for both of them, the graph and solving it. Number 12 says J minus 5 is less than or equal to 5. You're undoing minus 5 just like we undid minus 7 on the last one. Add 5. If you add it to the left, you add it to the right. J is something. 5 plus 5 is 10. Again, I keep saying that is something part because you have to determine if you need to reverse the symbol or not. All we did was add 5 to both sides. We did not multiply or divide by a negative number. So less than or equal to remains less than or equal to. J is less than or equal to 10. Less than or equal to 10. When you graph it, you're going to show two numbers again, just like we did on the last one. Always 2 of them is enough to show what you need. You just want to show that it's positive. Unlike number 11, that was negative, show it on the right-hand side as being positive. Less than or equal to means color the bubble in the or equal to part, just like number 11. Less than, since we have our variable j going first, it's pointing that direction. We're going that way. So just like number 11 was. A minus 2 is greater than 3. Undo minus 2 by adding 2 to both sides. So notice we're doing the same operations for 11, 12, and 13. It'll cancel it out on the left-hand side. 3 plus 2 is 5. All we did again was add 2 to both sides. We did not multiply or divide, and it was not by a negative number. So we're going to leave greater than as greater than. We do not reverse it. A is greater than 5. When we graph that one, again, you have 2 things you want to show. It's positive, so show 0, show 5 on the right of 0. And it's greater than 5, not or equal to like 11 or 12 is. So this time you do not color the bubble in. Leave it open. Greater than is pointing that direction, and the A comes first, so you're graphing that direction. So notice how that one's different than 11 and 12 as well. Number 14 says x over 5 is greater than 3. You can read that another way as x divided by 5. You cancel out division of 5 by multiplying that side by 5. If you do it there, do it here. It'll cancel it out on the left, and it'll leave you with something. 3 times 5 is the number 15. Okay, we multiplied this time. We multiplied both sides. That's part of what we need to do. But we don't multiply by positive numbers to reverse the symbol. We would have had to multiply by a negative number. So we're going to leave it say greater than, just like it is. X is greater than 15. When you graph that, just like the last 3, you're going to show 2 numbers. It's positive, so show it to the right of 0. Greater than means you do not color the bubble in. You leave it open, not or equal to. And the x comes first, so graph, it's going to the right side. You're going to the right as well. Okay, the next one, number 15, says negative x over 2 is less than or equal to 2. This is one of those examples where if you count your negative as being at the bottom, it'll save you a step at the end. So x over negative 2 is less than 2. Notice instead of just having the negative in the middle, normally we think the negative's at the top. It makes it easier for us, especially when we're talking about slope. In this case, it says to divide by negative 2. Putting the negative at the bottom is the difference between doing it in one step or two steps. We'll do it in one right here. That says to divide by -2. Cancel out the division of -2 by multiplying by -2, just like number 14, except it's negative this time. If you do it to the left, do the same to the right. Multiply it by -2. It'll cancel the left and leave you with x. 2 times -2, opposite signs are always negative. 2 times 2 is 4. The difference between this one and number 14, though, is instead of multiplying by a positive number like 14, now you're multiplying by a negative number. And now is the first time we take this less than or equal to and we reverse the symbol and call it greater than or equal to -4. When we graph that, again, you're showing two numbers. It's negative, so show it on the left side of 0. Greater than or equal to means we're going to color the bubble in because we're counting the number. And greater than, the x comes first. It's showing that direction. We're going to graph the same direction to the right. Find the x and y intercepts. Remember, in order to find the x and y intercepts, you're plugging in 0 in place of the opposite variable. So if we want the x-intercept, we're going to plug in 0 right there. -8x plus 8 times 0. That's the plug-in we did. Or that's the substitution we did, equals 32. When we simplify this, remember, anything times 0 is 0. It eliminates that part of the problem. -8x plus nothing equals 32 means -8x equals 32. And when you undo that, you divide. So you have -8x. When you divide by -8, you do the same to the other side, divide by -8, and you get x. A positive divided by negative is a -4, so your x-intercept is -4. When we look for the y-intercept, we're going to do the same thing, except this time you plug in 0 for the opposite one, for the x. So you have -8 times 0 this time, plus 8y equals 32. And remember, anytime you multiply anything times 0, it cancels that part out. So it leaves you with 8y equals 32. And when you divide by 8 on both sides, just like the last one, except it's positive this time, a positive divided by a positive is a positive. So your y-intercept is 4.